Hello and welcome, audience, to today's interview with Jev Gamper. Hi, Jev. Hi. I'm your host, Chanon from Warwick Artificial Intelligence. So Jev is a PhD student in the Maths of Systems program at the University of Warwick. He was part of a research team that used artificial intelligence to confirm the existence of 50 new planets outside of the solar system with no human input. Their findings were published on the 20th of August in the monthly notices of the Royal Astronomical Society, and we've put a link in the description if you want to have a read for yourself.
Hi, I'm Taras from Warwick Aerospace. I think they would have heard the introduction of Jev.
Yeah.
Say hi, Jev.
Hi, hello everyone. If you can hear me now, glad to be here. Everything is fixed. Guys are doing a great job.
Okay. Yeah. So, first question, Taras.
Yeah. So just to start off, would you be able to tell us about your involvement in the project to discover these exoplanets?
Absolutely, excellent question. So I should close myself because I can see myself. It's terrible in this YouTube. I closed the YouTube. Now I can't see anything there. So how I was involved. So it started all in my master's year. Towards the end of our master's year, we had to look for projects, and Theo and David, the co-authors of the paper and my supervisors at that time, proposed this project. They were like, hey, let's fit some machine learning models to classify if it's an exoplanetary signal or if it's a false positive. And we decided, and I was like, yeah, sure, I'll do that. And mostly my involvement was in writing code of the machine learning models, testing them, training them, writing up the first report, essentially to submit with masters, and learning more about astronomy, because I don't know anything about astronomy. So yeah.
Do you think you'd ever work in an astronomy-related project again, or was this kind of your one ride?
It certainly is an interesting field, and there is a lot of cool things to discover or learn about, but I don't think I'd be very useful there, because sure, I can fit machine learning models to all sorts of data, but it is the domain expertise that a person may have within that problem, like an astronomer, is what's valuable, because they are able to point out this is the problem that needs to be solved. And then me as an algorithms person, I can come in and say, okay, we can solve this problem with this particular algorithm, but it's them who are able to identify the problem in the first place. And kind of you have to work together. I can't be there just by myself, essentially.
But surely that's still an important role to play of kind of coming in and helping them find that right algorithm.
Yes, that is an important role to play, but it's not the answer that is often important. It's having the right question what's important.
Makes sense.
What attracted you to astronomy in the first place?
So that's kind of a longer story, because at first for my undergrad I was studying finance and economics and maths, and wanted to be a quantitative trader and learned all about investments and trading. And then I've kind of figured out that it's all kind of pointless, and that kind of made me drift to something completely opposite, like astronomy. I was like, well, this seems cool, this is actual science, like finding out new questions to ask, and that's how I drifted towards that.
Very interesting.
Makes a lot of sense.
And also, to be honest, that was just one of the few projects that was left available.
I mean, that's always a fair enough reason.
Yeah. So how does the AI work on a technical level?
How does AI work in a technical level? So before talking maybe about how AI works on a technical level in that project, maybe it's worth to describe the problem.
Yeah.
So the problem is such that the goal is to quantify the frequency of exoplanets. These are planets in other solar system with respect to their orbital period, with respect to the size of these planets, and with respect to the properties of the host star within that solar system. So that's the overall goal of the Kepler satellite project. And what is a Kepler satellite? So Kepler satellite is a satellite out there in space. It's still out there. It's just broken now. So what it does, it has a massive mirror on the satellite, and that mirror points to about 4.5 million stars. And what it does, it records the brightness of that star. And by monitoring the brightness of that star, if you can imagine something passes by in front of that star, we will expect a dim in the brightness of that star. And then we essentially record that time series, essentially the brightness of the star over time. Then we look at all possible dips within the brightness of the star. We do estimation of all possible planets that could have, of planets with specific orbit that could have created the frequency of these dips. And then we, from that, extract the what's called threshold crossing events. These are some sort of crossing events in front of the star that were above certain threshold of significance. And then these further are classified into either astronomical false positive or some kind of technical false positive created by noise from the instrument, like Kepler satellite itself, or the data transmission. And then, or if it is not a false positive, then it goes further into the vetting process. And we were working specifically on the vetting process part, where the astronomers previously used follow-up observations, where they would point other telescopes or other some sort of measurements or whatever to see if that is indeed the planet. And more recently, with the abundance of data that Kepler has created, they started to look into the statistical methods to verify if it's indeed a planet or if it's some sort of false positive. And we work specifically on that problem of verifying if it's false positive or if it's a confirmed planet.
Right, yes. So at the heart of the process that is doing the validation and statistical methods, I read in your paper is a Gaussian process classifier. Do you want to explain briefly what is it?
Yeah, so Gaussian process classifier, kind of a bigger picture of machine learning in general. You, on one hand, can have parametric models, and the simplest parametric model you can think of is a linear regression, or you think of just a straight line. I think everyone learned in, I don't know, high school or hopefully undergrad what is a straight line is, which is essentially y equals slope times the data point plus some coefficient or the intercept. And these are the slope and the coefficient are your parameters. And there are all kinds of different methods to find the optimal parameters for to find the best fitting straight line for the data. The next step would be, actually, you can think of that there could be multiple straight lines to describe that data, and all of them are likely at different, all of them have different degree of being likely to describe that data. So that's called kind of Bayesian statistics. That's where you describe, you assign a distribution behind every parameter within your model, and then you find the posterior distribution over these parameters. It's still parametric, but there you kind of try to quantify the uncertainty within the parameters, or how uncertain you are about the straight line that you've picked. And the next step would be the Bayesian non-parametrics, where you assume that there are no parameters in your model, and you instead model the function directly. And that's what Gaussian process is. You essentially model the whole of data as a multivariate Gaussian distribution, and that allows you to have a distribution over all possible functions that describe your data. And that's what Gaussian process classifier is.
Okay. When you're training your classifier to classify these data as planets or not planets, then do you use the whole data set for training?
So there are particularities with creating the data set. Again, At that time, I had no clue about the data set, which was okay. And everyone can start on a new problem and slowly, time by time, figure out what needs to be done. And back then, I was lucky to work with David Armstrong, who actually sit right next to me as a supervisor, and I could go and poke him, and he would be like, "Okay, this is what you should be doing," or "This is what you should be doing." So that was nice. But he kind of pointed me to different NASA websites where they store different data sets. We've aggregated that data set, and the labels from which we knew which was what was confirmed planet and what was false positive, these were already derived by scientists before. So we were able to use those already confirmed and confirmed false positives and confirmed planets to create the data set that we've used. And it was about 4,000 different data points that we used. And then we did naturally cross-validation to estimate that we indeed kind of get significant results.
Of the new planets you validated, was there any that kind of is your favorite? Any really interesting one?
No, I don't think I'm qualified to speak about the planets and what properties do they have and which one is the most interesting, because that's certainly the job of an astronomer.
Yeah.
And I was not involved as much in saying, oh, this is definitely a new planet. I made an algorithm that produced the probabilities, and then also part of my task was to compare the probabilities produced by machine learning models against the other statistical methods that have been used before by astronomers. But I didn't actually go then and say, okay, yeah, this looks like a planet now, or this one not. What I did like, though, is the posters of planets made by NASA. These are really cool. I highly recommend anyone to look them up. Just Google NASA posters, Kepler 16b. That's a really cool poster. It used to be my wallpaper back then.
Let me step back for a second and play devil's advocate, because 50 planets doesn't seem like that much when there are probably billions of them out there in the universe. So why should we care about this discovery?
I guess the point. So to be realistic, or to be completely honest, it's often researchers name their papers so that they sound like whoa, so that you can pass a review process, or so that you get more clicks on the internet, and then you can get more citations. So that's the reality of the matter. What's significant is not the fact that there were 50 planets discussed, and this is, by the way, a very good question. What's significant is that we showed that from the machine learning point of view, the problem of classifying the planets and kind of drawing the line in between, hey, these are on this side, these are false positives, on this side, these are confirmed planet. The problem itself is very easy from the machine learning point of view. And what was even more interesting is that we showed that there were significant differences in between the predictions or classifications that we made as compared to the models that astronomers used previously. And that raises more questions, not just about our research, but also about the previous methods that the astronomers were using, and kind of creates a stimulus to go back to the drawing board and see actually what can we do better.
Do you think this will become the new kind of industry norm, or?
Well, first, I hope that astronomy doesn't become an industry.
Fair enough.
Although it seems to be moving in that direction, which is sad. And I hope that it also doesn't become the norm. So also we make a point in the paper that actually don't use just one model, rather use multiple models, because different models have different assumptions, and you need to be careful with those assumptions.
Right.
So for example, our model specifically disagreed on false positives, and the machine learning model can only learn to interpolate in between what it has seen in the training data. And the physical model that has been used by astronomers before, it has already all the scenarios that can create either a confirmed planet or false positive already embedded into the model. But if one possible false positive scenario has not been embedded either into the training data or as part of the astrophysical model, then both of these might make a mistake in the future. Does that answer kind of the question? Does it make sense what I said?
Okay. Good answer. Thank you.
So is there something that you can do to make yourself sort of cover these sort of unknown possibilities of false positives?
Well, in general, in any machine learning project, the independent, if you're working with astronomy data, or if you're working in classifying cats and dogs, or you're working in, I don't know, in finance data or remote sensing data, you always want to look at the data. So if you're working with images, you literally, actually, not so long ago, a few weeks ago, I was clicking through 12,000 of images to see what kind of data do I have. And that is quite normal because it allows you to build intuition. So even people who work on self-driving cars at Tesla, they will be actually, like, you can read Andrej Karpathy's blog, who is the head scientist at Tesla self-driving. He will actually say, like, so often I will sit down and just scroll through images myself to build intuition about what sort of data am I working with, what kind of corner cases there could be in the data. So the same way here in astronomy, we'll have to go back, look at these uncertain data points where both models disagree, and actually discover what is the underlying cause that makes them disagree. And from that, we might be able to have more intuition. Okay, how can we fix the problem by either adding kind of more false positive scenarios into astrophysical model, or trying to find a way to use the astrophysical model to simulate data points that we can then train machine learning model on.
Right.
If that makes sense. Yeah.
Makes sense.
That makes sense. So you're currently doing a PhD, so I believe this whole project was following from your master's thesis.
Yes, exactly, yes.
So what are you working on in your PhD?
So after the astronomy, I was then inspired, to go and do something that has practical application, and I went into medical imaging because that seems to be the case that will have an impact, which is again not true. It's simply that there was funding available in that PhD, so that's why I went for medical imaging. So again, kind of just to underline that I was simply lucky to be at the right place at the right time, and these opportunities came forward, which kind of also underlines the privilege that I have generally to be able to get a higher education, to then be able to get a master's, etc., etc. So yeah, that's important to keep in mind. In PhD, I'm working on medical imaging. These are histology images. These are 100,000 by 100,000 pixels images, very large images. You can't store them in memory if you try to open them. I mean, depends how much memory you have. You essentially try to break these images into smaller pieces and then feed them through the machine learning model, and then classify, like detect tumor or detect different type of cells, classify different diseases, all sorts of problems.
Has that been easier or, oh, sorry.
So my view of the problem is that the problem overall is easy. The problem overall, I don't think that medical imaging should be a research field anymore, an academic field. What I think it should be kind of, it's already ready to be, the models are ready to be applied in practice. What the problem is that there is not enough data to train the models so that they work in practice.
Mm.
And what happens, you have multiple different research groups, and they have their own little data set, and they will use that data set for as long as they can, not share it with anyone, so that they can make as many papers as possible. And that's how it keeps going. Of course, until someone will probably gather all the data together or find a way to share the data in between the groups, make a model, and then these models will be ready to be kind of deployed in practice.
And you're doing this PhD at Warwick.
Yeah.
Why Warwick?
Well, like I've said before, it was just like I was at the right place at the right time. There was funding available, and it seemed interesting at that time, so I just picked that.
Fair enough.
Either way, it seemed better than doing finance.
Hope there are no finance listeners on stream right now.
Well, those who are in finance and are listening now, it's not too late to switch to something else. Actually, Hubble telescope, I'm pretty sure that Hubble was a lawyer, and then he decided to do astronomy instead.
Well, there you go.
Wow.
There's so many people who do physics degrees and go into finance. Why not, do the opposite, do a finance degree and then go into physics?
Yeah, we should definitely reverse that. Or even better, not go into astronomy, go into, I don't know, politics, or into something, like non-profits. Go and do useful things, all kinds of things.
So can you think of any reasons why you might go back to finance? Perhaps.
Me go back to finance?
If you had to think of a reason.
If I had to think of a reason.
Anyone.
I mean, I guess you can theoretically think of a hedge fund that is so successful, but instead of making money for investors, it makes that money and puts that money into something useful, into like some actually socially important causes. I mean, you don't need to think of a hedge fund. Imagine Jeff Bezos. He has so much money. If he paid 100,000 every employee of Amazon, he would make all that money back in a week. So you could theoretically, you don't need a hedge fund like that. You just need to create you need to just build a society where it's okay to not try to be rich.
Right.
Makes sense. I think we've accidentally become a politics podcast. We're also aware that you're involved in a project called Servest.
Yes.
Which, to my understanding, and according to their website, is developing AI to predict the risks and effects of climate change. And that sounds like an incredibly important project. Would you be able to tell us a bit about your role in that?
Yes, I can tell about my role there. So there are a few projects that I worked on there. One of them was just detecting field boundaries, which is a remote sense. You essentially have remote sensing data, which are, instead of Kepler satellite pointing into space, you have the same kind of satellite pointing towards the Earth. And the two satellites that we were working with are Sentinel-1 and Sentinel-2. These are from European Space Agency. And Sentinel-1 is radar satellite. It penetrates the clouds. And Sentinel-2 is kind of like your regular camera satellite, except that it has more bands. And using the Sentinel-2, we would create composites. Composite is essentially the frequency of observation at a particular spot for Sentinel-2 is like 6 days. And if there are clouds on that spot, then sorry, you can't see anything what's underneath the cloud. So composite is essentially you take the mean per pixel across time, or median, to denoise the data. And then you create denoised data without clouds, and then you try to detect the field boundaries of different crop fields. So that was my first task. And machine learning is all the same. You just throw some data. I mean, no, it's not. You give it some data, you work on the most important is to decide on what is the objective that you try to optimize. Once that is set, you optimize over your ground truth and the data set, and then you have a model. And yeah, and there were some other things that we worked on. I don't know how much I can talk about them.
That's fair enough. Don't implicate yourself.
Yeah.
Is that something you think you'll stick with for a long time, or?
I have no idea.
Fair enough.
Ideally, I would like to do something that is useful, but I am yet to see what is it that is useful.
How is
I'm sure you'll find that there's plenty of things.
How is it working in the team there?
In the team where? At Servest, at my PhD, or?
Servest.
Oh, at Servest is excellent team. Really good team, really good mentorship experience. And it was also excellent experience for me to work with other people and learn a bit how things work in industry, how, I don't know, how management works, how financing works, how communications work, how anything else works, all sorts of things. I mean, it's a very young startup, so you have to wear multiple hats, and that experience of wearing multiple hats is really cool. Yeah, I don't know if that answers your question. Let me know if you have more follow-up questions about the team.
If you were to start a kind of machine learning startup tomorrow, dealing with any topic or field or anything like that, what would it be? What would you call it?
See, that's what I was referring to. It's kind of going back to that question you've asked about would I work in astronomy now? And I said that it's domain expertise that allows you to decide what is the relevant problem. So the question would be not what startup do I start so that I work with machine learning, but the question would be what is the relevant problem that needs to be solved? And then you think what is the possible solution to that problem?
Right.
And it might not necessarily be machine learning at all.
That makes sense.
What are you most optimistic about when it comes to the future of AI?
What am I most optimistic about? So I like to think. So recently I've been exploring many people might know of GPT-3 by OpenAI. It's a massive language model, and the way it is trained is just to predict. You literally feed lines of text to the model, and you condition on, I don't know, 4 words before, predict what is the next word after these 4 words. So that is the objective that GPT-3 is trained on. And they essentially trained the model on the whole of internet and a few books in English, German, and French, I think. 1 second, I need to drink some water. And what they showed is actually the model can do loads of cool things. Because of that conditioning on the previous words, you can show to the model different examples. And then given those examples, the model will try to then create similar examples. If you showed that you ask a question, it gives an answer, you ask a question, it gives an answer, then you ask it a question and it will give you an answer. So these kind of things. And people have shown all kinds of examples how you can adapt this model to write a code for you. So where you write description of what you want the code to do, and it will spit out the code in Python or in C or whatever. So all sorts of things it can do. And I recently wrote an article about the last polymath. So polymath is a person who knows multiple scientific fields, or if you can think of math polymath, it will be a mathematician who works within or knows about all different areas within math. So if you imagine you could train GPT-like model on all scientific publications, on all textbooks for all kinds of sciences, and then you can at least suppose that it could actually, because it kind of learns like how the. So there is a very nice quote from this book actually. Probability Theory, The Logic of Science. There is a quote there, and it says that the great mathematician sees analogies between different fields, and the excellent mathematician sees analogies between analogies. And you can think that GPT, trained on all kinds of different scientific texts, will be able then to kind of come up with new different scientific solutions to different problems that you might have within different fields. So that's kind of all very abstract and not very concrete, but I like to think about it. And if you go on bruteforceimagination.com, there is an article there where I write about that. So yeah.
Make sure to check that out.
Sounds incredible.
But you do have to be careful, because as these models become very powerful, there are also plenty of things that can go wrong with them. So like with GPT-3, what they showed is that it generates such realistic text. And they did a study where they had New York Times articles, and they had articles generated by GPT-3, and actually long articles. And the accuracy that humans get in terms of classifying if it's machine generated or if it's human generated text is 50%. So it's pretty much realistic text.
Wow.
And people need to be very careful about that. And it's a very open problem I guess in policy. What do you do about that?
That could be used for
sorry. Yeah.
That's fine. that could be used for possibly malicious uses, then?
Yes, possibly malicious issues, but my partner actually just recently raised a concern to me that I have not thought about myself. It could be used, for example, to generate articles about climate change, which can be used by climate skeptics or people who say that climate change is a hoax, that will use the scientific arguments and in a very convincing way to say that no, actually climate change is not real. So like kind of taking that argument that I was using, that it could be used to create new ways to solve science, is the same way it could be used to kind of use the scientific arguments against for what is right.
I think that all actually segs very nicely into my next question, which is that we've talked about the beneficial, or at least some of the beneficial applications of AI, but I can think of some pretty unsettling ones too. There's a growing body of discussion around AI being used for autonomous weapon systems, surveillance, disinformation. You brought up. Are you concerned about any of that?
Yes. I think that before even thinking about autonomous weapons, there are concerns that already happen today, or like the things that should be already concerning because they already happened. And one of those things, I don't know how many people have seen the Social Dilemma movie by Netflix. So I highly recommend checking that out. It's not the best movie because there are a lot of things that they don't talk about there, and it's and also the people who talk there are mostly engineers, while they should also go and talk to people who actually studied these problems, like sociologists, anthropologists, historians who work, or journalists. So the problem the Social Dilemma movie describes is the fact that we have all these recommender systems behind social media that recommend to us different things, and these recommender systems can be manipulated, like it was in the US elections, etc., etc. They can be manipulated, but no one really knows how they work. So even people at Facebook, they might not necessarily know why a certain notification has been sent to one or another person at that particular time. It's just that the recommender system determined that that is the optimal time and the optimal notification to send to a person such that they maximize their revenue.
Kind of on that note, I remember reading an article recently which posited that even non-machine learning related algorithms are becoming increasingly so complex that even the people who wrote those algorithms originally very much can't understand how they work and why they're doing what they're doing and everything around them. Mm-hmm. And do you think that machine learning is going to, what sort of impact is machine learning having on it, and what sort of impact will that have on machine learning?
Right. So what I would say is machine learning makes everything worse, because there is a tendency in society to kind of seek tech solutionism, where instead of looking at the root of the problem, we kind of say, oh, technology and innovation will solve this problem. And often that actually makes things worse and distracts from actually looking at the real solutions. So, like in this case, you can have a already complicated, I don't know, system, and then you say, okay, let me just replace everything by a neural net, and then you will have even less clue what is actually going on in the system. So that's how it can actually make things worse. So yeah, one needs to be careful essentially to be kind of tech agnostic. Tech is just one of the possible solutions to the problem, and more tech is also just one of the possible solutions of the problem. People just have to be honest to themselves, and it's kind of not be these tech evangelists that tech is the solution to everything.
One question in philosophy often asked is there such thing as free will? Do you think that the development of AI actually takes away our free will? or possibly freedom, for another word?
I don't know about AI, but even thinking about my life path, that I went into masters and then I went into the PhD, was it because that it's not like I was up until 18 years old before I went to the university. I always dreamt of becoming a PhD researcher. It just, again, I happened at the right time at the right places, and then I was like, oh, that sounds cool, I'll just go and do that. Mm-hmm. How much of that is actually free will, and how much of that is actually it just so happened? I don't know. Mm-hmm. So I don't know if that answers your question. And even before we think about AI, that's already kind of a complicated question. And yeah, I don't know.
So with social media, as you said, recommender systems are often used, but we also have cases when social media affects our choices in elections. Well, it does all the time, and it seems to have some effect on decisions we make every day. Do you think then that AI could take away our freedom of choice?
I see what you mean with free will. Yeah. That's a good question. I need 5 seconds to think about it.
All good. Time to go to a commercial break.
I mean, important to realize here is what do those systems optimize for? And these systems, as part of large corporations, they optimize for clicks. They optimize for the time you spend on the media and the time you spend on the platform in general. Because that's what will maximize their ad revenue. And what can happen then is, because of these systems not having any restrictions, these systems might pull out the worst out of us. That means, okay, we will all go and look into flat Earth videos, because that's really fascinating, and they're usually made in a way so that you can keep watching them nonstop. And they will have all kinds of crazy things said there. So yeah, in that regard, definitely these systems kind of modify our worldview or decisions, not necessarily by a lot, but by a very small step. And you could see that having real impacts even now during the coronavirus. Like, suddenly people were burning 5G, what they called antennas. I mean, how much of it how much of that can be attributed to the fact that YouTube is run by recommender systems? I don't know, but what's concerning is that YouTube in the first place has these sort of videos, or I don't know.
A complex issue.
Yeah. So there is so I highly recommend checking out Social Dilemma movie. It's not the definite answer to it, because, again, like I said, mostly people who talk there are engineers. They don't invite people who actually work within that field. So highly recommend to then checking out also kind of good skeptical reviews of the movie by like sociologists and psychologists. But there are also like other scientists like Ben Green. And last week there was a conference on anthropology and tech in London online, where all of these different groups of people came together to kind of discuss how can tech people work closer with sociologists and with anthropologists to actually look at the root of the problems and not just be tech solutionists. Oh, here's this complicated problem, how can we reduce it down to classification? Which often is the wrong thing to do. We can't reduce problems to classification, and classification might not be even the right thing to do there at all, and might make things worse.
So I think we'll go to audience questions. We did have a form, and we've got 3 questions. So first question is so it comes from a follower of Young Scientist Journal, and they ask, how far are the exoplanets in the project that were discovered? And is there any possibility of finding aliens in it?
Oh, wow. So the first part, I will have to be honest, I have no idea how far they are. Probably very far, and we won't reach them. Finding aliens is a tricky one, because, I mean, what we see when we look at the stars is past, right? But it's something that happened hundreds of thousands of years ago, or even more, way more. So how much is the modern human history? Is like 12,000 years, let's say, from the first time from the first building that they've constructed, and so the human history can easily fit within that distance. So so many things can happen, and I don't know if people heard. I highly recommend looking into Fermi paradox. That it's statistically likely to find life. We just happen to not find it, and there are multiple explanations why that might not be the case. Either because it happened, but then the creatures out there self-destructed, or because it just hasn't happened yet. And also that's why the things like the quantification of the frequency of the exoplanets and their orbital periods and their size and the properties of the whole star is important, because that kind of allows us to gather more information how often such things as Earth can happen, where there are right conditions for life to happen. But that's thinking that as if carbon-based life is the only life. I don't know. That's something that we probably need to speak to biologists.
And yeah, there's been recently, I believe, something about planets that could be more habitable than I don't know if you have heard.
Oh, was it something about Venus that they found a chemical there or something?
That's another thing as well.
Yeah, so I don't know anything about it, so can't say anything. Knowing that scientists like to make big claims to get attention, I don't know which side of it is that, if that was what they found, or if that was not. I guess we'll have to wait. But either way, that's exciting.
Would you prefer if there were aliens out there, not just specifically on Venus, but would you prefer if there were aliens out there, or do you want to be alone in the universe? I'm cool with there to be aliens. I just think that we have plenty of problems to solve here on Earth. I mean, there is not going to be another Earth, and we should be pointing more satellites probably towards the Earth. I mean, no, that's even wrong, because I'm implying that it is also a technological solution towards the problems we have, which is not necessarily true. But yeah, maybe it's worth to think more about that we are all living on the same planet, and what can we do for actually to make life better for everyone on the planet. And then if aliens visit us and they find out that we were able to build a nice planet for everyone, maybe then there will be peace, interstellar peace. Sure hope so. So we have another question from Nifesh, I hope I'm pronouncing that right, studying economic psychology and philosophy at Warwick. Now that is a cool degree. Where do you see artificial intelligence going in terms of aerospace in the future?
Aerospace?
Aerospace.
Oh, aerospace, as in, I see, I was like, aerospace, what is that?
Sorry.
Where does it go in terms of aerospace? Wow. I mean, I guess what you mentioned earlier, like automotive weapons, which is not the nicest thing. I mean, we should just not do those kind of things at all. So yeah, don't go into weapons. Anyone here who is from aerospace society and thinks of interning for Lockheed Martin, don't do that. It's not too late. Yeah, I guess that's where, and that's the unfortunate bit. Like, there's a video on YouTube on quantum computing, quite a nice one covering different stories. And then at the end of the story, they interview head of engineering at Lockheed Martin, where they say, "Oh yeah, we're on the forefront of quantum computing because we want to optimize the shape of the fire jets." And you're like, well, that's like, sure, we could find a better application of quantum computing than optimizing shape of the fire jet that will fly around killing people. So yeah, I can't think of any other application in aerospace of AI rather than optimizing I mean, I don't know enough about the field, to be honest, to answer that. I know enough about maybe AI, but again, I don't have enough domain knowledge to say anything about aerospace.
But broadly, a quite pessimistic outlook, with good reason.
I mean, there are sure if we think of like commercial flight or whatever, there are probably hyperparameters within the engineering. There are engineering hyperparameters to optimize in terms of how can we make it more fuel efficient. And for that, you can use things like Bayesian optimization, and under which you have actually Gaussian processes, where you try different hyperparameters, and given that hyperparameter combination, you get a solution, and what is the value of that solution. And Gaussian process underlying the Bayesian optimization allows you to explore efficiently the space of hyperparameters. So what is the next set of hyperparameters about which you have the least information that you should try and see what you can get out of it. So these are kind of useful applications, and Bayesian optimization has been used in all sorts of other experiments. It's very close to experimental design in statistics.
Makes sense.
And we have a question from Chris at the University of Warwick. How advanced do you see artificial intelligence being in 10 years, 25 years, and 50 years?
Well, I think over the 20th century and now 21st century, there have been so many predictions of singularity and that AI is going to happen in like 5 or 10 years or whatever, and it hasn't happened. So it's a good starting question, but it's not the question that you want to ask. Because no one really knows, because we don't know how the brain works overall. So it's better to then learn what these tools are and then meet domain experts and speak with domain experts. Okay, what are the problems that you have that we can try solving using these tools? Because that's where the point at which AI is here's some X and here is some Y. Let's learn the mapping from X to Y. That's all what modern AI is. And no more than that. And we can't call that intelligence any near time soon.
So perhaps you would think it would be better to talk to domain experts and try to use AI to solve problems and build AI from that point rather than sort of replicate the human brain.
So I guess you need both. You need kind of exploratory research at the edge of neuroscience and AI that draws inspiration from neuroscience and tries to create new algorithms. And sometimes you have breakthrough discoveries from doing applied research, where you try to solve one practical problem and you actually find that there are no available solutions or methods that solve that problem, and then you come up with something new that turns out to be very general. So you need both, and you never know what is the right way to go about it.
You were talking earlier about AI being able to potentially do a literature review of an entire field of knowledge. So kind of on that basis, do you think it would be possible for AI to someday itself become a domain expert and then kind of use that to build ever more kind of almost a pyramid of rising AI?
Possible. I don't know. I mean, the current systems, they're good at interpolating in between the existing data points. So that's where I see the benefit of it learning from all different scientific articles. But they're not always great at extrapolating to new areas. So like if you train a convolutional neural network to classify cats and dogs, and you feed it an image of a turtle, it will have no idea what to do.
Right.
And the same way here, if you if you train it on articles of general relativity and Newtonian mechanics, and then you feed it quantum physics, it will have no idea what you are doing to it.
Well, I'm afraid that's it for the questions. And Jev, thank you so much for coming on to talk with us today. It's been a real pleasure.
Yeah, it's been awesome with having being here, guys. Yeah, pleasure. I hope the audience enjoyed it too.
Hope so as well.
I'd like to thank Emily at Warwick Aerospace for helping to make all of this happen, and Young Scientist Journal for their support. Just for Warwick Artificial Intelligence, we are having our next talk on the 22nd of October at 6 p.m, which is an introduction to AI ethics. So this follows on.
Oh, excellent!
Perfectly.
Excellent!
So that is with Ben Gilbert, founder of AI Ethics London. More on our Facebook page.
Amazing.
Yeah. Thank you so much for watching.
Yeah, everyone should join that,
so
and
much.
finance people should run away from finance, and everyone should join AI ethics talk.
Thank you, Jev.
Unless they want to
so much.
become AI researchers.
Yeah, yeah.
Great.
Alrighty, thank you.
All right.
Thank you. And hope everyone has a good